Okay, I assume you've read and worked the problem. This is a calculator active one, so make sure you're not wasting time by doing things that your calculator can do. We've done a similar problem. I think it was like rainwater. Maybe it was the first problem. You will always have a question like this where you have something going in, something going out. Okay, so we're starting to get some of similar type problems here. So make sure you're studying the past ones. Part A, don't go too far. A lot of you did that on the first question, just g prime of 5. Your calculator does that. Take the derivative at a point command. G prime of 5, you get approximately negative 24.588. Boom, there's an easy point right there. Now, this is the part where everybody misses. Interpret your answer with correct units. So the fact that the derivative is negative tells me we're decreasing. So the rate at which gravel is arriving is decreasing at 24.588 units, so that's tons per hour squared at t equals 5 hours. A lot of people forget that part right there. So you have to have those units to get the point. And that's 1 point for the interpretation. It's either all or nothing. Okay. Part B, find the total amount of unprocessed gravel during the hours of operation. Well, G of T is the rate of unprocessed gravel. So we want to go backwards. We want the amount. That's the function, not the derivative. Remember, this is the derivative because it's a rate. It's right there. So I want to do the integral from 0 to 8 of G of T dt. Right? Because this is in tons per hour. So if I take the derivative or the antiderivative, I just get tons. So calculator, I get 825.551 tons. That was worth a whopping 2 points. I thought that was a pretty easy 2 points right there if you understand that this was the derivative. This is the rate in tons per hour. Okay. Part C is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5. Show the work that leads to your answer. Well, remember, this is the rate. This is the derivative, so don't take another derivative. So if I do find G of 5, I get 98.141. Now, keep in mind, that's how fast the unprocessed gravel is arriving, okay? But it also says the plant processes the gravel at 100 tons per hour. So since this is less than 100, okay, I'm not processing, or it's arriving. Let me read that again here. Yeah, so it's arriving. You have less arriving than you are processing. So the amount... Sorry, my pen's going a little weird here. Sorry. The amount of unprocessed gravel. Oh, my pen, bear with me. That says gravel is decreasing. Because it's arriving less than how fast you're processing. You're processing more than is coming in. So the actual amount of gravel is decreasing. Okay. Part D. This is the part that, I'm sorry. Part C was worth 2 points. Okay. Part D, a lot of people miss this. Well, I need an expression for the actual amount of gravel. Okay. So this is the amount of gravel. I'm going to call it like A of T. This is the amount. Well, it says you start with 500 tons, okay, but then you have so much arrived. Now, you kind of do this in part D. So that's the integral of G, but I don't want to use T. I want to use T here. So don't use the same variable, so I'll just use X. Because when I take an antiderivative, when I take a derivative, that would be G of T, which is what I want. So I want my variable that they tell me to use, T. Well, they didn't tell me in this case, but I want T at the top. Use any other variable in the expression. So that's the amount which is arriving, but you're processing it at 100 per hour. So that's 100 times T. Okay, so now I want a max. So I want to take the derivative. So that's 0. That'll give me G of T, which is exactly what I wanted by the FTC, minus 100. Set that equal to 0. It's calculator active. You end up getting 4.923 when you solve that. Okay. Now, I would not do a number line. I'm actually going to do a check of the endpoints and the amount. Because a lot of people miss points because they don't check those endpoints of 0 and 8. So we need to check those 3 places. Then that'll tell me how much I have at a max. So I'm going to use this. This is very key. That's why I wrote it. So if I plug in 0, I don't really need to actually plug it in. I know it starts at 500 tons. Tells me that in the problem. Plug in 4.923. Now when you plug in, remember you're plugging in for T. Okay, not X. So when I plug that in, I get 635.376. Plug in 8 for T, I get 525.551. Now it says, what is the maximum amount? So right here, I'm going to give it units though, tons. 3 points, but if you didn't check your endpoints, you didn't get credit for all that.